Okay, so this is basically like the bell work. This is sort of to get you ready for the idea of the fact that trig functions can have more than one solution as well, just like quadratics. Slightly different reason for the trig functions or the trig equations, but so let's check if pi over 4 is a solution. So if you had to just check that, then just plug it in and see if it works, right? And the sine of pi over 4 is? Okay, I'll use your version. Square root of 2 over 2. So 2 times square root of 2 over 2 plus the square root of 2, and that's supposed to be 0. Is that true? Okay. So this one is no. With 5 pi over 4, plug that in. What's the sine of 5 pi over 4? Keep in mind that 5 pi over 4, if you were to draw it, would be here, right? -1, square root of 2. So what's the sine of 5 pi over 4? I like this one better, but for this sake, we'll use this one. This 2 cancels that 2, right? So is it true now? Okay. Is that the only spot on the unit circle? I mean, not even on the unit circle. Is that? But let's keep it between 0 and 360. So is that the only spot if we're within one? If we're within one rotation where that's true? Where else? 7 pi over 4 would also work, right? Why? Well, if you're at 7 pi over 4, you still get a negative over here, and you still get the square root of 2 over here. So the sign, again, is a negative square root of 2 over 2 or a negative 1 over the square root of 2, either one. And so there are 2 solutions here. Are these the only 2 solutions then out there? If we keep it to one rotation, yes. If we take that restriction away, are these the only solutions out there? No. Why not? What else can happen? It will keep going. What do you mean with that?
The next rotation.
The next rotation. And how long is the next rotation for a cosine or a sine? Plus 2 pi plus 2 pi. Is that it? Just 2 pi? That's it, guys? Just vote no? What's next then? Or plus? That's it. Just one rotation more and then that's it. So now there are 4 solutions. You can keep going. So 4 pi, 6 pi, 8 pi. Alright, so the way that you write that, you just put a k in here, with k has to be an integer then, okay, and it's sort of defined to be that way. So if k is an integer, then this works, right? You plug in 1. You could plug in a negative 1 too. Does that make sense? We haven't even talked about negative angles, but if you plug in a negative 1 here and rotate a negative 2 pi, you'd still be in the same spot, right? So trig equations end up having this kind of stuff on there a lot when you solve them. Because well, the sine and the cosine take on the same value twice within one rotation, so they have 2 answers usually. And then after that, you got to take into account that if you keep rotating, either positive or negative, you're going to get that again and again and again. So that little till over there, that's why we have it. All right. So we're going to do more of these, though. We're actually going to solve these. So where do I start? Where do I start? What if this was 2x minus the square root of 3 equals 0? Where would you start? Okay, well, I'm doing the same thing then. Okay, so move it. Then what? Square root of 3 over 2. What quadrant am I? Probably 4? Okay, I was thinking 1, but that's okay. We could be in 4th. I'm going to draw it in this quadrant first. So that's 1, that's the square root of 3, and that's 2. Yeah? So what angle is that? That's pi over 6, right? Because that's 30 degrees, so 6 30s into 180. Plus, if I keep rotating by 2 pi's, I get there again and again and again, right? I'm going to skip this part. Okay? Cosine's period again is what? Okay, so that's where that 2 pi comes from. And then, Catherine already mentioned something about, well, she said I was in 4th. Would this triangle still work in 4th quadrant? Yeah? So this one was pi over 6. What's this one then? This is, it's a pi over 6, but not pi over 6. Okay, so yeah, we could do it with a negative pi over 6. We could say, well, theta is a negative pi over 6 plus 2 pi k. That would work. This restriction is placed a lot on it, so we might start with 11 pi over 6 as well, plus 2 pi k. So both of these will work. Okay, and I don't, in this one it doesn't matter which one will you write. Probably the first one is easier, the negative pi over 6. Alright. So because you could really sit here, and this is why I already eliminated the list 8 of the solutions. I mean, you could list infinite solutions. So that's often we restrict our answers to only within the first rotation. So that changes the answer slightly, but we still need to take into account that whole 2 pi k, and you'll see that in a second. So let's see. If I start solving this, move the 1, right? Divide by 2. Yes? Okay, draw the angle that goes with it. So the adjacent is 1. What angle is that? That's pi over 3. So what's equal to pi over 3? Two theta is equal to pi over 3. Are you guys okay with that? Okay. Plus 2 pi k, right? Are you guys okay with that? And then you solve this for theta by doing what? What do you need to do to get rid of the 2? Don't we just divide by 2? So this ends up being a pi over 6 plus pi times k. So right now, theta could be pi over 6, and you got to be between 0 and 2 pi. So can I add pi to pi over 6 and I'll still be between 0 and 2 pi? So 7 pi over 6 is an answer. If I add another pi, I would be at 13 pi over 6, right? So that one doesn't work anymore. So that's it for the first one. But that's only one spot where this works. The other spot would be where? The cosine is still positive when you're over here, right? Because I want my answers to be positive anyway, I'm not going to use a negative pi over 3. I could, but I'm just going to straight go, I'm going to go immediately for, this one is what in terms of positive rotations? This is 5 pi over 3, right? You guys okay with that? So if 2 theta is equal to 5 pi over 3, then it also works. And then any rotation after that. Well then, solving for theta, you have to half all of these. So if I start at 5 pi over 6, that will work. But don't forget to half this, so this 2 disappears. So the next spot that this will work is 5 pi over 6. and then you add pi one more time. So what's 5 pi over 6 plus pi? So that would be 11 pi over 6. So even though it restricted us, and that's a pretty big restriction, you still ended up with 4 answers. Why did you end up with 4 answers here? What caused the 4 answers in this case? Other than the fact that the cosine is, well, it has a period of 2 pi, so the values keep repeating. Why do I have 4 answers? Why don't I just have 2 answers? Like here I only had 2 answers. Here I only had pi over 6 and 11 pi over 6. Right, and then we added the rotations to it because it didn't say, you know, your answers had to be between 0 and 2 pi. What made it different here? The what? Not sure that that's what I'm looking for. Anybody? Do you think the 2 here made a difference? Okay, I want you to think about that and see if you can sort of reason your way through that, because that's important. When you see that's called the argument. When the argument's different than just theta, so if it's 2 theta or theta over 4 or 3 theta or 5 theta, it's going to change your answers. Okay, because you're plugging in here for theta, but you're multiplying it by 2. Well, in this case, it actually created some more answers for us. All right, you see this again. Next one. So it starts the same way. So the square root of 3 times the tangent of 3 theta is equal to a -1. Divide by the square root of 3. So it's a -1 over the square root of 3. Draw a picture for it. So the tangent needs to be negative. So the first spot that occurs is over here, right? So opposite is, in this case, that's the 1 and that's the negative. So here is one location where my tangent is negative. So what angle goes with this? This is another 30-degree angle, right? So this is it's a pi over 6. How many pi over 6? How many pi over 6 is to get to here? Not 4. 5, right? Because if this is pi, then this would be 6 pi over 6. Yes? Jake, you had a question?
No.
Okay. Alright. Oh, okay. You were right. Okay. So that means you do what? What has to equal 5 pi over 6? 3 theta has to equal 5 pi over 6, right? And then here it's different from the sine and the cosine. What's the period for the tangent? So here you just do pi times k. Does that make sense? Or k pi, I guess. Let's keep it in the same order. Alright, and then I need to solve that equation so I can find my final answer. So k times pi. So divide by 3, then this would be 5 pi over 18 plus k pi divided by 3. So this gets to be a little annoying here in a moment. Okay, where else is your tangent negative? In quadrant 4. Now that's your negative. Okay, so this is what? This is a pi over 6. How many pi over 6? 11, right? Okay. So 3 theta also could be 11 pi over 6 plus k times pi. Divide by 3. So it's 11 pi over 18 plus k pi over 3. Okay, now I'm going to list all my answers. Between where and where do I need to stay? What's the biggest number I can give? 2 pi. Okay. To easier compare it, 2 pi, if I write it as pi over 18, would be 36 pi over 18, right? I can go up to 36 in the numerator. Yes? So 5 pi over 18. And then I'm adding pi over 3's, right? Yes? And pi over 3 is actually pi over, if I want to make that an 18, I need to multiply by 6, right? Yes? Yeah. Alright, so 5 plus 6 is 11 pi over 18, plus 6 is, plus 6 is, plus 6 is, and plus 6. Yes.
I don't see anything 18 is on the bottom.
You don't see why I have an 18 on the bottom?
Oh, because of 3.
Yeah. Divided the 3 out, so this ends up.
So 6 times 3.
Yeah. Yeah, I needed to make it a common denominator. Are we okay with those?
So how do you do 6 pi over 18?
I took pi over 3. I took pi over 3 and wrote it as 6 pi over 18 so that I can just add 6's in the top. Because k is an integer, right? So it's 5 pi plus 1 times 6 pi. That's 5 pi plus 6 pi. So 5 plus 6 is 11. And then plus 6 is 17. Plus 6 is... So keep adding 6's until you run out of room. Okay, now let's check here. Do I already have all these? Do I already have all those? Yeah, we sort of lucked out here. 11 pi over 18 is one of the numbers here. So if you keep adding 6 pi over 18s to it, you ended up with all of them already. Okay? You guys okay with that? Alright, so what about this one? This one's sort of set up for us already. So this represents an angle, right? Alright. So at what angle is your cosine 1? Your cosine is equal to 1 where? I think it's 1 at 0, right? And at 2 pi again. And so if 0 is included and 2 pi is not, this one only has one answer. It's at 0. So that means that I have theta minus pi over 4 is 0. Yeah? Plus 2 pi times k. So theta is just equal to pi over 4 plus 2 pi times k. So listing all the answers here, keeping in mind that I have to be, since I have to be between 0 and 2 pi, there's only one answer here, because pi over 4 plus 2 pi is more than 2 pi. So there's only one answer here. Are you guys okay with that? Clearly we can make these more difficult too by, moving the 1 to this side, dividing by a number and all that, and disguising it, but you end up with the same principle. So I just wanted you to see that you treat this the same way that you treated the 2 theta and the 3 theta. Alright, the last one. So some of these are calculator based, because we don't, is that an angle that you know? Have you ever seen 0.2? Is that a special triangle type of value? So hopefully you're thinking no. What do you have to make sure that you do with your calculator? This is what? That's radians, right? So you do inverse cosine of 0.2, make sure you're in radians, and then that will give you an answer. So if you do that, you get 1.37. Are we okay with that? What quadrant am I in at 1.37? I'm in first, right? You already knew you were in first because of this. Okay, the cosine's positive in quadrant 1. So 1.37 is probably somewhere over here. So that means that your angle could be 1.37 radians plus 2 pi times k again, right? Yes? Same thing? Okay. What else could it be? In 4. So that's like a negative 1.37, right? If your angle has to be between 0 and 2 pi, so if you have to keep this in mind, and this is 2 pi, then how do you find this angle? You can just do 2 pi minus 1.37. So the other angle that's possible would be 4.91 plus 2 pi k. What was that? Well, the full rotation gets you to 2 pi, right? And I am 1.37 away from there, so if I do this, that gives me this angle, but instead of as a negative rotation, it gives the angle as the positive rotation that I need, because I need to be between 0 and 2 pi. Does that make sense? Okay, so keeping this in mind, just subtract that answer from 2 pi. And then look at this one more time. If you add 2 pi to anything, you're past the 2 pi, right? So the only answers that you can have are 1.37, because the next one is past 2 pi, and 4.91. So this one only has 2 answers again. And keep in mind that I asked about this earlier. This is just theta. So when you get just theta and you are between 0 and 2 pi, you probably should only expect 2 answers, because if you add 2 pi to what you started with, you're past 2 pi. Does that make sense?